A particle moves along the parabolic path y squared equals x in a way such that the y-coordinate of its position increases at a constant rate of 10 meters per second. So in other words, dy dt is equal to 10. It starts at the origin and t seconds later is located at the point P here, xy. When at P the particle is at a distance of r meters from O, and the line OP is inclined at an angle theta radians to the horizontal, as we can see here. Show that tan theta is 1 over y. Well, tan theta is just going to be y over x, and we're told that y squared is x. So that's y over y squared, which is 1 over y, and r is y, 1 plus y squared. Well, r, being the hypotenuse of this right-angled triangle here, is just going to be the square root of x squared plus y squared, and x is equal to y squared, so that's y to the 4 plus y squared, which is the square root of y squared into 1 plus, or y squared plus 1, and then we can slip this outside the square root, so that's y root 1 plus y squared. When the particle is 2 meters above the horizontal line OM, so that's y equals 2, at what rate is theta changing? So we want d theta dt. We have dy dt, so we could use this here. If we differentiate, then we get sec squared theta d theta dt is equal to y to the negative 1 differentiates to negative 1 over y squared dy dt, because we differentiated both sides with respect to t. Now, if y is equal to 2, that tells us that tan theta is equal to half. We know that tan squared theta add 1 is sec squared theta. We could have just done this on the calculator, but I'll do it like this. So that's a quarter plus 1 is sec squared theta. So sec squared theta is 5 over 4. So 5 over 4 d theta dt. We know y is 2, so this is minus a quarter dy dt. Dy dt we know is 10. So d theta dt is going to be 4 over 5 times negative 1 quarter times 10. These 4's cancel. This cancels with this. So that's negative 2 radians per second. At what rate is its distance from O changing? So this time we want dr dt. dr dy would be equal to, remember this is y, 1 plus y squared to the half, so we need to differentiate this. It's a product, so we'll have this one times this one differentiated, so that's just 1 plus y squared to the half, plus this one times this one differentiated, so that's y times half 1 plus y squared to the negative a half times the differential of the inside, which is 2y. So what we've got is the square root of 1 plus y squared plus 2y squared over 2 root 1 plus y squared, and the 2's cancel. So we know from the information given above that we're looking at when y is 2, so dr dy would be equal to root 5 plus 4 over root 5. Now, dr dt would be equal to dr dy times dy dt. So that's going to be the root 5 plus 4 over root 5 times 10. So we'll calculate that. So that's giving us root 5 add 4 over root 5 times 10, which is 18 root 5. Perhaps we should have that as a decimal. So we'll just change it to a decimal, 40.25. And that would be meters per second.